Okay, this is 7.1 again, and number 19. In number 19 in the book, they actually give you the graph, but I want to show you how to generate the graph from these two equations, and then that'll cover one of the methods for finding a point of intersection is just plain graphing it. You know, graph two lines and you can actually then see the point of intersection. So the easiest way, in my opinion, to graph this is to reorganize it, move the furniture. I call this moving the furniture. Just moving that over there. So y equals negative x plus 3. I'm getting it in y equals mx plus b format, so I can quickly graph it. So now we're going to do the same thing over here. We're going to add 2x to both sides. That's gone. And now y is on this side all by itself. I'm going to, just like I did over there, I'm going to switch places with these so it's in mx plus b format. And my students know that the b part is the y-intercept. So on the graph, if we were going to graph this thing, 1, 2, 3, there's the y-intercept, so we know we have 1 point. And then we use the slope, which is a negative, and there's like an understood 1 there, so it's really a negative 1, which written as a fraction is a negative 1 over 1. So if it made you feel more comfortable writing 1 over 1 so that it really does look like rise over run, then do that. You know, this is the rise, that's the run. So negative 1 would be our rise from that point we plotted, rise a negative 1, and then run 1. And that would give us our line. And now we go to negative 6 for the intercept, the y-intercept of that one. 1, 2, 3, 4, 5, 6. There's 1 point on the line. And then we rise 2, because the only way we could write that as a fraction is 2 over 1. Rise 2, run 1. And I'm going to go ahead and continue that process just to try to be a little more accurate. Rise 2, run 1. Let me put some tick marks here. So rise 2, run 1, rise 2, run 1, rise 2, run 1. I bet right there is where I would actually end up with this one. Down 1 over, down 1 over, down 1 over, yeah. Kind of crooked there. But that's where they would actually intersect. And if you draw your graph on really accurate graph paper, it makes for a little bit more easy time seeing the accuracy of the lines. So, looks like our point of intersection is in x value of 1, 2, 3, and y value of 0. It's right at 0. So 3, 0 is our point of intersection. So you might want to write it here. And like I said before, there's really no excuse. I'm going to erase part of this to make room for my checking, because I was raving in my previous video about how students, there's no excuse for getting it wrong, because you should take the original equation, x plus y equals 3. Plug the x and y back in there. 3 plus 0 equals 3. So obviously, yes, that works. Now over here, we have negative 2x was our original equation. And if we plug in, what was it, x and y. Well, I'm trying to hurry. My camera battery's about to die. X and y. So this is a negative 6 plus 0. Obviously that is true, yes. So that checks out. Now I know I did it right. And that's the way any diligent student should go about it.